In the following presentations, we look at potential control options for the weed Poa annua. Poa annua is one of the great challenges turf managers face in maintaining quality turf surfaces, as a plant is one of the 5 most widely distributed plants in the world. It is found on all 7 continents, most recently on Antarctica. Poa annua follows human disturbance almost anywhere. Poa annua has a high degree of variability that allows it to survive in a variety of environments. As a weed, it produces prodigious number of seeds, even on golf course greens mowed at or below 1/8 of an inch. Those seeds, too, can accumulate in the soil and persist for years before germinating. To give you an idea of the amount of Poa annua seed that can be produced, a study found that a meter squared area of Poa annua could produce between 150,000 to 650,000 seeds per year. In cool, temperate, and Mediterranean climates, Poa annua can form an excellent golf course turf on tees, fairways, greens, and roughs. This is Oakmont Country Club in Pittsburgh, Pennsylvania. The tees, greens, and fairways are Poa annua, maintained at a high level of intensity. This is a golf course in Portugal. Under the Mediterranean climate, Poa annua predominates across the entire golf course. Here in Northern Ireland, Royal Portrush, which hosted the Open in 2019, is almost entirely Poa annua from tee to green. Given that, Poa annua thrives at low mowing heights and where temperatures are not too hot nor are they too cold. You would think Northern Europe, Germany for example, or around Paris, France would be a perfect climate to grow Poa annua, which it is, but controlling Poa annua might be desired in these locations. Microdocium patch is a major cool, wet weather disease of Poa annua. From early fall through late spring, this disease can be devastating on golf courses through Europe. In the United States, a number of fungicides can control microdocium patch. In Europe, however, pesticides are being banned on golf courses and other turf areas. Although the climate may be ideal to maintain Poa annua as a desired turf, without being able to control, in this case, a single disease, the quality of the turf is poor. We usually think of Poa annua as either an annual type or a perennial type. The annual type is shown here growing in the pot. It has the characteristics of an annual life cycle, germinates in the fall, develops through the winter and into early spring, and then produces a profuse amount of seed heads prior to dying during the heat of summer. The light-colored spots on this practice putting green are Poa annua. If you look close, the plants in the patches are producing seed. I took this picture in spring on a golf course in South Carolina. The green is a hybrid Bermuda grass infested with Poa annua. In this case, the Poa annua is an annual type. Later we will mention Poa annua control in Bermuda grass. It is much easier to control Poa annua in warm season turf grasses than cool season. The second type of Poa annua is the perennial type. It acts like a perennial plant. The perennials over time predominate, especially on putting greens, over the annuals when maintained at low heights of cut. One of the questions that has been raised is how does a turf, a putting green for example, convert from the initial invasion of an annual type to a perennial type? Are annuals the initial colonizers that successfully integrate into the existing turf grass, followed by the more stable perennial types? In a study out of Penn State University, researchers looked at a wide collection of annual and perennial biotypes from golf courses and other turf areas from around the country. They took these various biotypes, characterized them as an annual or perennial morphologically, and crossed them. After numerous crosses, they found that the progeny did not follow expected Mendelian ratios. When they did back crosses, they found that the perennial types reverted to annuals within a few generations. It appears that under close mowing like greens and tees and to some extent fairways, the functionality of the DNA may be affected, giving a perennial type, but the underlying DNA is not affected. This is known as an epigenetic effect on gene regulation. An example of an epigenetic effect without changing the underlying DNA would be the addition of a methyl group to part of the DNA molecule, which would prevent certain genes from being expressed. What are the drawbacks to Poa annua as a desirable turf to manage? The grass is susceptible to several environmental stresses like winter injury. Its tolerance to cold temperatures and freeze tolerance are poor. Does not survive a continual ice cover as long as, for example, creeping bentgrass or Kentucky bluegrass can. And as mentioned previously, it is susceptible to winter diseases. During the summer, the heat tolerance and drought tolerance are poor. Much of that poor drought and heat tolerance is due to a shallow root system. This is a Poa annua fairway coming out of winter in the Detroit area, suffering winter injury. Specifically, freeze injury caused the damage. This is a green in the Detroit area. Here's winter injury in the Pittsburgh area. Chicago. In this case, a large part of this fairway had been sodded a year prior with creeping bentgrass. Note that there is no doubt the difference in susceptibility to winter injury of these two turf grasses. Switching seasons, this is a Poa annua fairway in Chicago, suffering from several factors, but the underlying stress is heat. One of the factors that impacts Poa annua management during the summer is its shallow root system. The lack of a root system makes management difficult. Basically, there is a small room for error when managing Poa annua compared to other cool season turf grasses. Too much or too little water and heat can push Poa annua over the edge. Additionally, the shallow root system of Poa annua is a detriment to an athletic field's playability. This picture was taken at the old Wembley Stadium in London. Maybe if you look close, you can pick me out from among the four gentlemen. The soccer pitch is a Poa annua turf. It looks great. However, given the shallow root system, the field is easily ripped up from soccer players playing across the field. It is a poor field, and the turf needs to be replaced. Just for your information, the new Wembley Stadium was opened in 2007 on the site of the old Wembley Stadium that was demolished in 2002-2003. As we look at specific control measures for Poa annua, we need to ask, why is it there in the first place? The gist is that if we don't change the conditions that resulted in Poa annua being there in the first place, the likelihood of it coming back is high. As an example, this picture was taken at a golf course in Detroit. At the time, I was a graduate student tagging along with my major professor when he took this picture. Given that the picture is old and the sign erected by the club is difficult to read, it says, "Our goal has always been to provide you, our golfing member, with the very finest golf course playing conditions available." Since it's impossible to have a truly first-class golf course with a second-class grass, better known to the turf grass specialist as a failure grass, we have undertaken that gigantic task of ridding our golf course of Poa annua. A couple of things stand out. One is second-class grass, and it is known as a failure grass. There is a reason Poa annua is there, and it's because that the original grass either died or the Poa annua crowded it out. I like to say, if creeping bentgrass dies, what fills in? Poa annua. When perennial ryegrass dies, what fills in? Poa annua. And finally, when Poa annua dies, what fills in? You got it, Poa annua. So I don't think it's a failure grass. I returned to that course several years ago, and guess what? It's all back to Poa annua. The only good thing when I returned was I didn't see all that polyester. As you can probably tell, at this point I need a break. In part 2, we will look at specific control practices.